Good evening, folks. Good evening, very good evening to everyone. So this is your physics teacher Arun for the class of electrostatics. You know, in that especially electric potential, right? So in the previous classes we have discussed about how exactly we are supposed to consider the problems of electric forces, how exactly you are supposed to consider the problems of electric fields, and in today's class we are going to discuss about electric potential. Fine. So now let's get into the class very quickly. So before I get into the class, obviously, so let us see how exactly the what exactly the plans of an academy. I would like to give you the details regarding that. The best plans for Karnataka KCET 2021 aspirants are hereby as follows. One is 12 months plan for 12,375. So you can approximate for 1,031 rupees per month, or you can purchase a plan of three months, so sorry 6 months, that is for 10,125. So approximately you're going to get it is 1,688 rupees per month, or you can take the trial of 1 month, that is 2,250 for new subscribers only. Those who have already got subscribed will not be getting that one. If you have if you are a new subscriber, you can avail this plan for 2,250 rupees only, right? What are the contents which we have under these plans? One is the premium content at the affordable prices, structured live classes plus dedicated live doubt clearing sessions, quizzes at the regular interval of time for self-analysis, batches for complete preparation, test series for DPPs, full-length mock test, etc. with analysis, single subscription for unlimited access, right? So you can use my code Arun K Live for the best discount possible under the Unacademy, right? In a similar way, we have started a comprehensive batch on the Unacademy Plus, so which consists of complete syllabus complete syllabus will get covered, the tips and tricks by the top educators, topic wise practice questions, full and mock test. You can have a look at that for with the help of by paying 250 rupees till the end of September 30th. Almost there's only 3 days left to avail this plan. It has got already started from September 1st itself, right? You can use the same code Arun K Live so that you can get the best discount possible, you know the among any of your plans which you want to subscribe, right? Now, so before we get into the problems, I would like to give you a brief introduction of electric potential so that you can solve the problems very clear, right? Yes. Since we are solving the problems on electric potential, we must know what do you mean by electric potential first, right? So to understand that, let me consider say I have a charge q. I have charge q at some point in the space, and I have another charge q naught at infinity. Why I am calling this term as infinity? Because why I am calling this distance as infinity? Because, right, there is a small logic behind it. What is that? In the previous classes, if you have a look at it, we have explained the concept of electric field. What do you mean by an electric field? The region or the space around a source charge where the electrostatic force of attraction or repulsion due to a force in the source charge should not get experienced by the test charge, right? Then where exactly is that? I'm considering that region to be infinite. Andra, if you consider a source charge, around it you can build a cube. You can build a sphere, because why I'm considering sphere, it's a 3-dimensional object, right? If you start building a sphere around the source charge, you can extend that to infinity. That is, there will be a force getting applied. So at infinite point, we consider that the electric field due to a source charge would be equal to 0. Fine. Now from this infinite point, whatever the work you do. What do you mean by a work? Work is nothing but force into displacement, F dot S, right? Whatever the work you do in bringing that test charge, against the electric field of a source charge, that work done is called as electric potential. That work done is called as electric potential. What do you mean by electric potential? We can see the potential at a point in an electric field is defined as the amount of work done in bringing a unit positive charge, the amount of bringing a unit positive charge from infinity. Why I have considered infinity? Just now I explained it, right? From infinity to that point along any arbitrary path, right? The work done will be called as what? Electric potential, right? Since you're calling a work done as electric potential, work done is a scalar quantity, so electric potential is a scalar quantity, right? Since you're calling electric potential as a work done, yes, work done is a scalar quantity, obviously electric potential must also be a scalar quantity, right? Then how did it define? V is equal to work done in moving a unit positive charge. Work done in moving a unit positive charge. V is equal to W divided by Q naught. We can write it as joule per coulomb. The unit of work done, the unit of electric potential is joule per work done. Joule per coulomb, joule per coulomb, right? We call this joule per coulomb as a volt. Andre, what do you mean by 1 volt? If 1 joule of work done in moving a charge of 1 coulomb from infinite to a given point, then that kind of work done is called as, then the potential required is called as 1 volt, right? Okay, that's fine. Yes, you can write the dimensional formula also. It is 1 in M, 2 in L, minus 3 in T, and minus 1 in A, right? So the types of electric potential, right? There are 2 types of electric potential: positive potential and negative potential, right? Positive potential would be positive under what case? Potential would be positive under when the source charge is positive. Negative potential would be under what case? The potential would be negative under when the source charge is negative. Under, say I have a charge Q. What is the potential at a distance of R due to this? If you ask me, means yes, the potential would be equal to, due to a point charge. We know the equation due to a point charge. What is that? It is 1 divided by 4 pi epsilon naught into Q divided by R, right? Now, since the source charge is positive, potential is also positive, right? See, in a similar way, V is equal to 1 divided by 4 pi epsilon naught into minus Q divided by R. We consider that when the source charge is negative. If the source charge is negative, the electric potential would be negative. If the source charge is positive, the electric potential is positive. Sir, however, if I have 3 system of charges, say I have a charge Q1, a charge Q2, and a charge minus Q3. I am supposed to find what is the potential at a distance, at a point P, the distance of R1, this is the distance of R2, and this is the distance of R3. Means then the potential at a point P, Vp, is given by K into Q1 divided by R1 due to Q1, right? In a similar way, K into Q2 divided by R2 plus K into minus Q3 divided by R3. Or we can write this one as what? V is equal to, we can take out K common. It is Q1 divided by R1 plus Q2 divided by R2 minus Q3 divided by R3, right? This will be the potential at a given point. For n number of charges, what is the potential, sir? Apply the superposition principle, right? What does superposition principle says? There it was a vector sum. In force and in electric field, it was a vector sum. But here it is a scalar sum. It is directly the addition of the potentials due to every individual charge at a given point, right? Now, electric potential due to the continuous charge distribution, obviously, right? So what is this electric potential due to a continuous charge distribution? Normally we consider in what is this? in practice, normally we consider yes, an object, say an iron rod. If I take example, there you will be having millions or trillions or billions of atoms, right? There, this individual concept of individual charges we cannot come into the picture, right? There we consider that the charge is not the integral multiple of charge carrier. Instead, we call it as charge is continuous. So there we find the electric potential. There we find the electric potential V is given by integral of V. A small integral you consider, integrate that one, you are going to get the answer. Right? Next. So the very important one, I'll come to this one. 7th one. What is that one? Let us see. This one is one of those things, if you study, you can understand that one. No need to worry about that. Right? Potential due to concentric spheres. Potential due to concentric spheres. Sorry, before that, potential difference. Right? What do you mean by this potential difference? Right? What do you mean by this potential difference? See, let me consider a source charge. The source charge. I'm going to consider A and B be the 2 points. A and B be the 2 points. Fine. If VA is the potential at A and VB is the potential at B. If VA is the potential at A and VB is the potential at B. So that, let me consider this is at a distance of R1 and this is a distance of R2. Then difference between these 2 points, VA minus VB, right, is called as potential difference. Final minus initial always. Remember, final minus initial. It is nothing but K into, due to the charge Q, it is Q divided by R1 plus the same charge Q divided by R2. Right? It has to be minus. So I can write K into Q is common, it is 1 by R1 minus 1 by R. This is the potential difference between what A and B. Its basic definition itself is going to go like that. Since you are bringing from infinity, what is the initial point? At infinity, right? What is the final point? It is A. So it's a distance of R1. So R2 value will become equal to what? Infinity, right? If that becomes infinity, 1 by infinity is 0. So you are like we have written, VA minus V infinity is equal to much K into Q divided by R, or simply VA is equal to K into infinity divided by R. That is, the potential at infinite point is always equal to what? 0. The potential at infinite point is always equal to 0. Right? Now, next. Now, there is one more thing to be understood. What is that? We are supposed to find the relation between electric field and electric potential. We are supposed to find what is the relation between electric field and electric potential, right? So what is that relation between electric field and electric potential? Yes, this is relation between electric field and electric potential is given by E is equal to minus dV by dr. E is equal to minus dV by dr, right? So what does this minus sign indicate? No, no, minus, obviously it never means that, it is always, it is always opposite in direction. No, it is not like that. It means that the negative sign indicates that, you know the electric field is always, in the direction of, decreasing potential, it will be always in the direction of decreasing potential, right? That's it, nothing else, right? Now the one more thing is the very important one, is how to find the electric potentials due to concentric spheres, right? Okay. Now, due to two concentric conducting shells of radii R1 and R2, right? Due to two concentric shells of radii R1 and R2, right? Now, such that R2 is greater than R1, carrying uniformly distributed charges, you know, carrying uniformly distributed charges, potentials at the surface of the each cell is how much, right? So you are supposed to find what is the potential at the each surface, right? So surface of the each cell. How to do that? Let us see. So, you already have a potential. You already have a surface, a sphere of radius r1, such that the charge is q1, right? So what is the potential on the surface of this due to this charge? It is V is equal to 1 divided by 4 pi epsilon naught into q1 divided by r1. Let me explain it clearly. Yes. So this is your potential, right? This is your sphere, and this is the one more sphere, right? This is R2, this is q1, this is q, right? Now, so you know that the electric field inside a sphere is always equal to 0, right? Electric field inside a hollow sphere is always equal to 0, but inside the solid sphere it is not equal to 0. That part also you must remember, right? So if inside a hollow sphere electric field is 0, then what about the potential? The potential V remains constant inside a sphere. Say I have a sphere of radius r, such that it is carrying a charge of q. Then what is the potential on the surface? V is equal to 1 divided by 4 pi epsilon naught to q divided by r, right? So what is the potential inside it at any point inside the sphere? The same, that is 1 divided by 4 pi epsilon into q divided by r. Whatever there is on the surface, that remains the same inside it, right? Coming to the potential due to the smaller sphere on the surface of the bigger sphere. How it is that? At a distance of r1, it is V is equal to k into q1 divided by r1. Similarly, at a distance of r2, it would be plus k into q2 divided by r2. That's it. On this bigger sphere, if you want to find, change this one. Plus, due to its own sphere, what is that one? K into q2 divided by r2. Right? Now, what is there on, what is the potential on the lower surface, inner surface? V is equal to what? K into q1 divided by r1 on its own surface plus K into Q2 divided by R on the surface, right? As simple as that. Try to understand and so that you can simply score it, right? Now you're having three spheres A, B and C. You're having three spheres A, B and C, right? Now you're finding the potentials of that. Now potential due to the smaller sphere on this surface and on this surface, that is how supposed to find, right? Now so let me write that one also. Right. So I have three spheres. This is of charge Q1, this is of charge Q2, and this is of charge Q3. On the outer surface, if I want to find, means V on the outer surface would be equal to 1 due to its own surface, right? That is K into Q3 divided by R3. Similarly, plus due to this second sphere on the sphere of the outer surface, that is K, charge is Q2, but what is the distance? R2. Similarly, this one, same, it is K into Q1 divided by R3, this is also R3. Right? You're supposed to consider both of the distance now, right? Similarly, on the middle sphere now, on the middle sphere, right? So due to the smaller sphere, first K into Q1 divided by R2, right? Because distance is going to get varied, right? Plus K into Q2 divided by R2 due to this own surface. Now, since this 2 is inside the third sphere, so I can say K into Q3 divided by R2. Right? Now, on the smaller sphere now, Vm is equal to K into C. Due to that own sphere, it is Q1 divided by R1. Am I correct? Plus, due to the bigger sphere, the middle one, whatever the potential is there on the surface, that remains same throughout it. So it is K into Q2 divided by R2. Right? Similarly, due to this third sphere on this one, that is whatever the potential on the surface of the third sphere, that remains same throughout it. So it is K into Q3 divided by R3. Right? This is the value on the smaller sphere. Right? So this is how you're supposed to find the potential due to the concentric spherical shells. Right? Try to understand so that you can clearly solve the problems. Fine. Next. So let me go to the problems directly, because those were the similar. The other two were the similar things. So if you get a surface which is got earthed, if the outer sphere is earthed, the potential on this would be equal to 0. The potential on this would be equal to 0. Then, how to solve such kind of problems? If potential on the bigger sphere is equal to 0, it does not mean that the charge on it is 0. Only the potential would be equal to 0. Say, if this is carrying a charge of Q1, then it is going to induce minus Q1 on this inside sphere, inside surface of the sphere, right? Now, you can find what is the potential due to that. That's it. Right? Now, potential of the inner sphere you can find, right? Potential of the inner sphere you can find. Yes, you can find that one here. They just, as we have solved in the above problem, you can solve it similarly, right? Okay. Now, two conducting spheres of radii R1 and R2. Two conducting spheres of radii R1 and R2 have same electric field near surfaces. Try to understand. Now. Two conducting spheres of radius R1 and R2 have same electric field near the surfaces. Right? Yes. two conducting spheres of radii R1 and R2 R1 and R2 have same electric field near the surfaces. Andre both are having the same electric fields, right? The ratio of the ratio of the electric potentials is right. What is the ratio of the electric potentials? We are supposed to find, right? How to find the ratio of the electric potentials? We are supposed to find, right? Now to find the ratio of the electric potentials, just now we were discussing what is the potentials on the surface. They are of radii R1 and R2, right? They are of radii R1 and R2. So if I have a a sphere of radius R1 carrying the charge Q1, radius R2 carrying the charge Q2. Diksha Bhatt, sir, volume is low. Sir, speak loudly. Okay. Let me check the volume. Yes, it is fine. Okay. if I have two spheres of radii R1 and R2 having the charge Q1 and Q2, then potential due to this V1 would be equal to K into Q1 divided by R1, right? In a similar way, potential V2 is equal to K into Q2 divided by R2, right? I think I'm able to use Diksha. I'm able to I'm a bit louder now, right? Now, so to get the ratio of V1 over V2, so K and K will get cancelled. So Q1 by Q2 multiplied by R2 divided by R1, right? So I have got Q1 by Q2 is equal to Q1 by Q2 into R2 by R1, which is the ratio of the potential. Do I have the answers? No, I have only in terms of radii, right? But they have given me a hint that the electric field near the surfaces of C, right? Andre electric field due to Q1 E1 is equal to what? That is K into Q1 divided by R1 square is equal to K into Q2 divided by R2 square, right? K and K will get cancelled. I can write the ratio of Q1 divided by Q2 is equal to R1 square divided by R2 square, right? So if I can substitute this equation number 2 in equation number 1, I can clearly write the ratio of V1 by V2, that is Q1 by Q2 is R1 square divided by R2 square multiplied by R2 divided by R1, right? R1 and R1 will get cancelled, R2 and R2 will get cancelled. So V1 divided by V2 is equal to R1 by R2 must be the answer for ratio of the potential. That is option C must be your answer, right? Diksha, can you hear me now? Okay. Next, three charges plus Q, Q and minus Q are placed at the equal distances on the straight line. Three charges plus Q and minus Q are placed at equal distances on the straight line. If the total potential energy of the system of the three is 0, then the ratio of Q by Q is option A 2:1, option B 1:2, option C 2:3, and option D it is 3:2, right? So let us find what is the potential energy of the system now first, right? Now, what is the equation for potential energy, guys? So U would be equal to 1 divided by 4 pi epsilon naught into Q1 into Q2 divided by R, right? For a system of two charges, right? Now, what I am having plus Q and minus Q. I have three charges, right? So what they have given you? I have three charges Q, It is at the distance of another you have plus q, and at the distance of another you have minus q, right? So they have been given that place that equal distances on a straight line. Place that equal distances on a straight line, right? Now say it has been kept at a distance of r, means this has been also kept at a distance of r, right? Now what is the system of this, what is the potential energy of the system? Let us try to understand. Now for a single charge, note, we always define potential energy as the work done in moving a charge from infinite point to any point in the electric field, right? Now for one charge we don't have any sort of potential energy, or this will not have any sort of potential energy. But when the other charge is moved to a distance of r, then potential energy due to this 1 and 2 is given by 1 by 4 pi epsilon naught into q divided by r. This is due to these two charges. Next, when the third charge is bought, you have an electric field of this plus q as well as another plus q, right? Then I can write due to the small q and due to this plus q, right? Both, that is minus, because this charge is minus, so it is 1 divided by 4 pi epsilon naught into q divided by 2r, because the distance between them is 2r. Similarly minus 1 divided by 4 pi epsilon naught into q divided by r, right? But what is given in the question? If the total potential energy of the system is 0, right? Total potential energy of the system is, that is u value is 0, then what I can do? If it is 0, I can take out 1 by 4 pi epsilon naught common. Even I can take out small q also common. So q by 4 pi epsilon naught r, if I take common, what you have left with? Q. Here it is q divided by 2. Here it is minus q. Right? Now this would be equal to 0, right? If this is equal to 0, what you have left with now? You need the ratio of, right? You need the ratio of q over q, that is small q over capital Q. Don't forget that one. You need the ratio of q over small q, right? So you can write. So it is, second, yes, okay. Now it is 2q minus q by 2, or simply 2q is equal to q by 2. I need the ratio of it, so I can write q by q is equal to 2 by 2. Sorry, q by q is equal to what? 1 divided by 4. Capital Q by small q is equal to 1 by 4. Right? Do I have the answer? No, somewhere I did the mistake then. Right? So this is 2r. Okay. This is r. Between these two it is r. Okay. This is r. Okay. Yes. Where exactly I have done the mistake? Yes. Charge value was wrong actually. Yes. The value of charge was wrong. Yes, correct. Yes. Charge value was wrong. That is, the third charge which has been placed, it is nothing but minus 2q, right? So it becomes, it is 2q, right? It is 2q means it becomes q, right? If that becomes q means now q by q is equal to 1 by 2. Yes. The answer is the 1 is to 2 must be my answer, right? I have written this, I have typed the charge wrongly. Sorry. Next. Okay. You have one more question now. That is, in an electric field of charge plus q, a charge q moves from A to B. A charge q moves from A to B, right? In an electric field of q, that is, here you have plus q, right? A charge q moves from A to B as shown. You have moved from A to B, right? Now The work done is, how much you're supposed to find, right? How will you find the work done? Let us see. See, you have a charge plus q here, and you have small q here at a distance of r. This is a, and this is somewhere it is b, right? This is at a distance of what? R from this point, right? Now V, how do you write V as? W is equal to Q, or V I will write as what? V is equal to, always it is a potential difference, B VB minus VF, final minus initial multiplied by Q, right? What is the potential at B due to the source charge? It is K into Q divided by R, right? In a similar way, what is the potential at A? It is minus K into Q divided by R multiplied by charge Q, right? This is capital Q, this is also capital Q, right? So minus when we will get cancelled, so it's 0 into Q. So work done would be equal to what? At B, the potential is, sorry, the work done in moving a charge from A to B is 0, right? Next. A charge plus Q is placed at the origin of XY axis. A charge plus Q is placed at the origin O of XY axis is as shown in the figure. Fine, is as shown in the figure. The work done in taking a charge Q from A to B along the straight line AB is, right? You're supposed to find what is the work done, in taking a charge Q, from A to B, right? So what is given in the question, try to understand first. You have a charge plus Q at this origin, right? You have charge plus Q at the origin of XY axis, right? Now the work done in taking the charge from taking the charge Q from this A to B, right? A simple thing to solve. How to solve that one? How to solve it, right? At this origin we have O, right? So at a point, this A, that is A comma 0, right? This A comma 0. Now, so this is B, right? B is B comma 0, sorry, 0 comma B, right? So this is the point B, right? Now until now we have been discussing about one dimension, right? Now you could see this is in 2 dimensions, right? It has moved from x axis to y axis, right? You could see this problem. You can read the question once again if you want. So a charge plus Q, a charge plus Q is placed at the origin, right? A charge plus Q is placed at the origin, right? So it will spread the electric field around it. A charge plus Q is placed around the origin, right? XY axis is of the XY as shown in the figure. Now you're supposed to find what is the work done moving from A to B. Illi now apply ಮಾಡಿದ್ರೆ it is a motion, it's in 1 dimension. R we have considered, but illi hagagalla, right? You are moving from A to B, that is in 2 dimensions, right? Now how to get that one? Let us see. What is the potential at A? What is the potential at A? Yes, let us write what is the potential at A. The distance of A from this, the distance of A from this O. So VA is equal to 1 divided by 4 pi epsilon naught into Q divided by A at a distance of A, right? Because you have placed a charge plus Q at a distance of A. You are moving this from here to here, right? So it is VB is equal to 1 divided by 4 pi epsilon into Q divided by B, right? Q divided by B. Now how do you write the work done? W is equal to, just now we have done final minus initial multiplied by what? A charge which you are moving, that is plus Q, right? Now what is VB minus VA? It is k into q by b minus k into q by a, right? Multiplied by q. You can take out kq common, so I can write this one, k q into q multiplied by 1 by b minus 1 by a, right? So I can write this one as k q into q into multiplied by a minus b divided by a into b. This must be the answer, right? K means nothing but 1 by 4 pi epsilon. Fine, we shall write it 1 by 4 pi epsilon itself. So work done is equal to k is 1 divided by 4 pi epsilon naught q into q multiplied by a minus b divided by a, right? Now we can make out easily q into q into a minus b divided by a. So option A must be your answer, right? Simple question. So because the concept is similar, right? The concept is similar. Next. Yes. A bullet of mass 2 grams, a bullet of mass 2 grams is having a charge of 2 microcoulombs. A bullet of mass 2 grams is having a charge of 2 microcoulombs. Through what potential difference it must be accelerated? Starting from rest. Through what potential difference it must be accelerated starting from rest to acquire a speed of 10 meter per second. Try to understand a simple question. You have nothing big to solve in this one, right? A bullet of mass 2 grams is there. The mass of the bullet is there. It is 2 grams. And the charge of the bullet is 2 microcoulombs. Fine. Now, I am keeping it in an electric field of potential difference, say V. So a bullet is there, right? It's of charge 2 microcoulombs and mass 2 grams. 2 grams or 2 milligrams it is. Let me check once. Yes, it is 2 grams. Okay. Now, so it is kept at rest. Now, if you place it in an electric field, so that what happens? Positive and positive will get repelled in this direction. Positive and negative will get attracted in the direction. So it will begin to move, right? Once it begins to move, it has to acquire a velocity of how much? It is 10 meter per second. It has to acquire a velocity of v. V value is how much? It is 10 meter per second. Until that, you are supposed to accelerate that. Fine. Then at what potential difference you are supposed to keep that you are supposed to, right? Now, so it has been accelerated. It has got a mass. It has got a charge. Very good. Now, how to find the potential? Right? How to find the potential? How I can relate with the potential is the question, right? See, the force which is getting applied here, is nothing but electric field. Am I correct? The force which is getting applied here is nothing but electric force, right? The force which is getting applied here is nothing but electric. How do you write it? It is Q into E, right? The force is given by Q into E. By the definition of electric field, I am writing force over unit charge, right? Now, see, initially it has been kept at rest. Finally, initially it has been kept at rest, right? The final velocity is there. V is 10 meter per second. 10 meter per second. U is 0, right? V is 10 meter per second. U is 0, right? Because it has to acquire a velocity of 10 meter per second. See, if you have any doubts, you can read the question one more. What is that? A bullet of mass 2 grams. A bullet of mass 2 grams, right? A bullet of mass 2 grams, and having a charge of 2 microcoulombs. Now, the simple thing I am supposed to do is I have to relate the potential difference with the velocity, right? Because you have the charge of it, right? If you have the charge of it, right? If you have the charge of it, right? And if you have the mass of it, right? if you have the mass of it, you can relate that with, because the force is getting applied is nothing but a electric force, right? Now you're supposed to relate all these things. That's it, right? How I am going to relate this one? Let us see. See, when it is beginning from rest, it is going to gain the velocity. Hence, it has gained kinetic energy at that. How that kinetic energy is nothing but the work done by the electron, right? W, or you can write V is equal to W divided by Q naught, or W is equal to V into Q naught, if I am not wrong, right? Hagadre, this W can be replaced by, see, kinetic energy equation is how much now? Half m into V square, that is equal to V into Q naught. Don't cancel this V and V. This is velocity, this is potential difference. Fine. Now, so I need the value of V. So I'm going to write in that terms. So V is equal to m into V square divided by 2 into Q naught. Right. Now I can write the mass of this is 2 grams, 2 in 10 power minus 3 kgs, multiplied by velocity is 10 square, that is 100, divided by 2 into charges 2 in 10 power minus 6. 2 and 2 will get cancelled, 2 and it is 250. So now it comes to numerator, becomes plus 6. So V would be equal to 50 into 10 power 3. Right, 50 into 10 power 3. That is 50 kilovolts. Right, option D is 50 kilovolts. Did you understand, guys? Are you following the classes? Now, a spherical drop charged drop of water carrying a charge of 30 picocoulombs has a potential of 400 volts at its surface, right? If 8 such drops are combined to form a single drop, then potential on the surface of the single drop is ನೋಡಪ್ಪ ಈ ಥರದ ಕ್ವಶನ್ ನಿಮಗೆ ಸಾಕಷ್ಟು ಬಾರಿ ರಿಪೀಟ್ ಆಗಿದೆ ಇನ್ ಯುವರ್ KCET ಆರ್ ಯುವರ್ ನೀಟ್ ಅಥವಾ ನಿಮ್ಮ ನಾರ್ಮಲ್ ಎಕ್ಸಾಮಿನೇಷನ್ಸ್, ಇದೆಲ್ಲ ಕಡೆ ಕ್ವಶನ್ಸ್ ಈ ಥರದ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ, ರೈಟ್? ನಾವು ವಿ ಆರ್ ಸಪೋಸ್ ಟು ಫಾಲೋ ದ ಶಾರ್ಟ್ ಕಟ್ ಫಾರ್ ದಿಸ್. ಸೊ ಲೆಟ್ ಅಸ್ ಡಿರೈವ್ ದ ಶಾರ್ಟ್ ಕಟ್. ನಿಮಗೆ ಜನರಲೈಸ್ ಮಾಡಿ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿರೈವ್ ದ ಶಾರ್ಟ್ ಕಟ್. ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ಶಾರ್ಟ್ ಕಟ್ ಟು ಸಾಲ್ವ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್. ಫೈನ್. ನೌ ಸೊ ಲೆಟ್ ಮಿ ಡಿರೈವ್ ದ ಶಾರ್ಟ್ ಕಟ್ಸ್. ಏನಿದೆ, ಸೊ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಡ್ರಾಪ್ಲೆಟ್ಸ್. You'll be having small droplets. Say there are n in number, fine. They combine to form a bigger one. Please note down the shortcut which we are deriving, fine. They combine to form, they collide to form a bigger droplet. Now, what exactly has got changed? Say each having the charge Q ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, the total charge on this is n into Q. The total charge is n because charge is additive in nature, that's it, right? ಇಲ್ಲಿ each of radius r ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, the small droplet each of radius r ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, this cannot be equal to n into r. ಯಾಕೆ? Why? Because a droplet is a sphere. The radius of it cannot get added directly. It is going to add and get 3 dimensions. Andra, the volume of it is gets increased. The volume of the sphere starts to increase, not only the radius, right? Now so how to find that? See, n times the volume of the small sphere must be equal to volume of the bigger sphere. Simple as that. N times the volume of the small sphere must be equal to volume of the bigger sphere, right? Now, what is that volume of the small sphere? How do you find the volume of small sphere? It is 4 by 3 pi into r cube, that is equal to 4 by 3 pi into capital R cube, which is of radius capital R, right? Small r is the radius of the small sphere and capital R is the radius of the biggest sphere, right? 4 by 3 pi will get cancelled. Now what you have left with? R cube is equal to r by 3, r by 3, so r cube divided by n, right? R cube divided by n, right? Now, sorry, I want the reverse, no, because I already know the value of small r cube, r, right? So r cube is equal to n into r cube, or simply I can write r power r is equal to 1 power n by 3 times. Andre, this is the radius of the bigger water droplet, radius of the bigger water droplet, and this is the radius of the smaller water droplet, radius of the smaller water droplet, right? Now, n is what? Number of water droplets you have, right? Directly you can adopt to find the radius, right? In a similar way, potential of the bigger water droplet, potential of the bigger water droplet is equal to 1 divided by 4 pi epsilon naught into n into q divided by you know n power 1 by 3 times the r cube, so small r cube, right? Because smaller, right? Why? Normally, how do you write the potential of the bigger water droplet? V is equal to what? 1 divided by 4 pi epsilon naught into charge of the bigger water droplet divided by radius of the bigger water droplet, right? What is the radius of the bigger water droplet? Is n power 1 by 3 times the r. What is the charge on it? It's n times the q, right? So Vb is equal to, see, if I take out this n outside, n into n power 1 by 3, right, is there. It is 1 divided by 4 pi epsilon naught into q divided by r, right? This is nothing but the potential of the smaller water droplet, it is, right? That is Vb is equal to, if you simplify this, 1 plus 1 by 3 is how much? It is 3, 1 plus 1 by 3, right? How much is this? 1 plus 1 by 3, right? So 1 plus 1 by 3, right? Sorry, 1 minus 1 by 3, right? Because it has come to numerator, right? 1 minus 1 by 3 must be equal to n power 2 by 3. N power 2 by 3 times the potential of the small water droplet. This is the equation which we can use directly. If you have these two equations, that is equation to find the radius of the bigger water droplet, and because sometimes they may ask you radius, sometimes they may ask you potential, sometimes they may ask capacitance also, right? So equation to find the potential is Vb is equal to n power 2 by 3 times the potential of the small water droplet. Keep the things in mind, fine? Now, what has been asked now? For the given question, let us apply now. A spherical charged drop of water carrying a charge of 30 picocoulomb, has a potential of 40 volts. Right? See, a spherical water droplet of water, a drop of water carrying a charge of 30 picocoulomb has a potential of 400 volts, right, at its surface, right? Now, if 8 such drops combine to form a single water droplet, right, then the potential on the surface of the single water drop. How to do that one? Simple, no? Yes, we have the equation. What is that equation? Now, the things will get simpler if you have this one, right? Potential on the bigger water droplet is equal to what? N power 2 by 3 times the potential of the smaller, right? N is how much here? How many number of water droplets you have? It is 8. If 8 such drops, right? So it is 8 power 2 by 3 into potential of the smaller water droplet, right? What is the potential of the potential of the smaller water droplet is 400, right? So 400 multiplied by 400, right? So 8 power 2 by 3 can be written as 2 cube into 2 by 3. Cube and cube will get cancelled, so multiplied by 400. 2 square is 4, 4 into 400. So the answer must be 1600 volts. That is potential. Right? How much time it took? It took only 20 seconds. Right? I just checked what is the number of water droplets. Right? I just checked what is the number of water droplets. I just checked what is the potential on it. Just solving it. Else it will consume too much of time if you don't have the shortcut. Fine? Next. Charges 10 by 3 into 10 power minus 9 coulombs. Charges 10 by 3 in 10 power minus 9 coulombs are placed at each of the four corners of a square of side 8 centimeters. The potential at the intersection of the diagonals is. The potentials at the intersection of the diagonals is how much? Simple, a simple question, right? You have a square. You have a square of side 8 centimeters, right? It's of side 8 centimeters. Right? Now the charges are how much? 10 by 3 in 10 power minus 9. 10 by 3 in 10 power minus 9 at every point, at A, at B, at C, and at D. Next, you are supposed to find what is the potential at the intersection of the diagonals, right? At this point O. Right? At the point O, you are supposed to find. So potential at O is given by VA plus VB plus VC plus VB. Like that. Right? Because all are positive, directly you can add it. VA plus VB plus VC plus VB. Right? Now, to do that, I need to know what is the distance of OA, OB, OC, and OD. Right? OA is equal to OB, that is equal to OC, that is equal to OD. Right? How to find that one? Apply Pythagoras theorem. This is 8 square plus 8 square. So this must be what? 2 into 8. Sorry, 8 square plus 8 square. 8 root 2 must be the answer of this. That is answer of AC. Right? What about this one? OA. It is 8 root 2 divided by 2. Right? 8 root 2 divided by 2 means how much it is? It is 4 root 2. The answer of this is 4 root 2. How? Square of 8 square plus 8 square. Right? So it is, if you take out 8 square common, it is 1 plus 1. So it is 8 into root 2. Right? So I need half of it, so it is 4 root 2. Right? Now, so V at O is given by, see, K I have took it common. You can take charge also common. Now, it is RA plus RB plus RC. This is also common. So directly I can write VO is equal to 4 times the VA. Simple. Now, 4 into K values 9 into 10 power 9 into Q values 10 by 3 into 10 power minus 9 divided by distance is how much? It is 4 root 2. Right? So 4 and 4 will get cancelled. 3 1, it is 3 3. So the answer, so 10 power plus 9 minus 9 will get cancelled. So it is 30 divided by root 2 into 10 power. So nothing we have left, right? It is centimeters, you can convert it to meters if you want. Minus 2 comes, numerator becomes plus 2. Plus 2. So it becomes 3000 divided by 2. Right? So it is given in root 2 numerators. So I can write that one also, nothing. Right? So V naught is equal to, how I can write this one? 1500 into 2 divided by root 2. If root 2 comes to numerator, becomes how much is that? If root 2 comes to numerator, becomes V naught is equal to 1500 into 2 into 2. Right? That is minus 1 by 2. Right? Not root 2, it is 2 power minus 1 by 2. Or simply 1 minus 1 by 2 is root 2. So V naught is equal to 1500 root 2 volts must be your answer. So this is all for today's class, guys. So keep watching Unacademy's YouTube channel and stay connected. Fine. Thank you.